If you're watching the video, pause and write all this down because I forgot to press record. Okay. Next thing we've got is acceleration. What is your formula for acceleration? Forget. Let's remember. What is the difference between speed and acceleration?
Isn't it like you're doing the same
It's not actually made up to net speed.
Okay? You're comparing speeds.
Yeah.
So the first part of your problem,
It's like 0 you start, like, because you start at 0, and then you go like 0 to 40 or something.
okay?
0 over like 60.
Speed, or however fast you're going, not distance. Both of these are compared to time. So your initial, what Ariel was saying here, this might be your final speed minus your initial or starting speed. All right, so if we want to change that and just get speed by itself, so we started with acceleration is the change in speed divided by change in time. Excuse me. What needs to happen to get speed alone? Yeah. Whatever's on the bottom gets multiplied on both sides. So delta S, or change in speed, is the change in time times your acceleration. And if we want delta T times A equals delta S, if we want to get the T alone, the A needs to move and it's multiplying, so we divide it. So delta T equals your change in speed over your acceleration. What is your unit for acceleration? Oops, wrong thing. Yeah. We're still meters and seconds, but now our seconds get squared because we have seconds in our speed and in our time. And then we're going to make up a problem for this one. Let's say you start you're driving, let's be responsible and go 45 miles per hour and abruptly stop. Abrupt, that's a P. It takes, let's change this, not miles per hour. Let's do meters per second. Say this takes 5 seconds, 3 seconds. It takes 3 seconds to stop. What is your acceleration? What are you going to do? Okay? You're missing one thing. We got to take in, yes, we were going 45. That's our first speed. Then what did we get to? 0. So we were going 45 and then we stopped. So that's 0 meters per second. When we were driving 45 miles or meters per second, what was the time? We're just trying, this when we start, what's our time gonna be? 0. And then it took how long to stop? 3. So remember, we're doing acceleration is speed divided by time, but what's your speed going to look like on top? 45, what's 0 doing? Subtracting. 45 minus 0. Hold on, what's the bottom look like? 0 minus 3. So 45 minus 0 is 45, but 0 minus 3 is negative 3. So your acceleration, negative 15, what's our unit? Squared. And it's negative because we slowed down. We decelerated. Okay? Okay with acceleration? Do we need to do another made-up problem? Okay. Okay, the next thing we talked about was force. For regular force, what's the formula? Yes? F equals ma. So force is mass times acceleration. If I want to solve that for mass,
Mass and what?
mass times acceleration. What do you need to do to get the m alone? Divide the a. So mass is force over acceleration. If I want to get the a by itself, what? Instead of having to multiply the a, what's that going to look like when I multiply a? Yeah. Just going to start with the same thing we started with. Because when I multiply a, I get back to f equals ma. What do I need to do to get the a by itself? Divide the m. So she's not in this class. So acceleration is force divided by mass. What are your units for force? Newtons. Isaac figured this out, so it's named after him. Yeah, Melissa's. The bacon. Oh my gosh. All right. If you see a question that says a car has a mass, a 1,000 kilogram mass. How much force will it take to reach 2 meters per second squared acceleration? I don't know. What did we say? What did they give us? Yeah, they gave us the m and the a. So all you need to do with those, multiply 1,000 times 2. So that's 2,000 what?
Meters per second squared. I just need
Newtons. Force. Makes these weird.
having that for myself.
Yes. Oh my gosh. Let's do another one. Let's say a train has a force of, I don't know, 5,000 newtons. If it's accelerating let's do 250 meters per second. What's its mass? So we've got newtons is a force. Okay. Yep. They want us to find mass, so excuse me, mass is force divided by acceleration. 5,000 divided by 250. So it's a teeny tiny train. Maybe it's just one car. Maybe it's a toy train. It's the Christmas train at the mall. Okay. How do you feel about force, mass, and acceleration? Easy enough. Okay. Next page. We've got gravity. So this is another force question. Gravity on Earth is always 9.8. They put 9.81 on here. If you just use 9.8, that's fine. If we're using gravity, we find force by doing what? Anybody remember the gravity force problem? Yeah. MGH is potential. This one is just NG. Work. We probably need to put that on here. Yeah. We used this equation and then we did the work ones with it. All right, so let's move this around. Force equals mass times gravity. To get mass alone, divide the gravity part. So mass is force divided by gravity. To get gravity by itself, same as last time, I just need to go back to the beginning and what needs to move? The mass. gravity equals force divided by mass. Work is when we add distance into these. If we're just using these basic ones though, what should we push? We're pushing a car? All right. You push. How big is your car?
Like how much does it weigh?
How many kilograms?
2,000.
2,000?
Not that much.
All right, we're pushing this 2,000 kilogram car down a hill.
Oh, if it's down a hill, it's pushed over and you go walking through it.
How much force did you need to use? Oh, I forgot to write the word force. Thanks. So to find force, what do we need?
Wait, what's the end stand for?
Mass. We're looking for F. So force is just mass times gravity. We're Hulk, okay? So what are we doing? Times 9.8. So 2,000 times 9.8. How much?
19,600.
We're multiplying. 19,000?
Yep. 600.
What is your unit for force? Newtons. The work formula. Okay, at the top of this page, we're also going to add in work. Work was the W, and it's force times distance. So for this one, it's kind of the same idea. Let's say you push a 100 Newton car. Oh wait, yeah, 5 meters. Yeah. What did I say? I'm sorry, 1,000 newtons. So this time the meters here is the difference. It's the distance, but it's what's different than the ones before. If they give you a distance, that's a work question. So how much work did you do?
Just divide, multiply by 5,000.
Yep. So we just multiply them. Work equals 5,000, oh, nope, 1,000 times 5. which is 5,000. What is your unit though? Work is a type of what? When you do an action, you're using energy. And energy is measured in. I don't want to fool you. I want you to get these questions right on the quiz.
So, will it ask, like, how much work did you do for a work question?
Yeah. Power is another type of energy. All of those energies are measured in joules. Capital J. So power, we should also add that one on the other side. Power has its own. It's work divided by time. So you say your car, when you pushed that, we did 5,000 joules of work. Maybe that took us 20 seconds. So how much power did we use pushing that car? Is it a do or use question? Use. How much power did you use? So the 5,000 would be which variable? Yeah, our work. And if we did it in 20 seconds, seconds is time. 250 something or just 250?
No, just 250.
Okay, the number is 250.
I'm saying something.
Oh, the unit. Gotcha. Power is in watts. What? Like your light bulb. That same thing.
You can't just throw these new ones out.
Alright, we got this. Question about gravitational acceleration. Work or power? No? Alright, the last two on here are what we just talked about this week. Potential and kinetic energy. What is your formula for potential energy? mgh, mass times gravity, but we're adding in height for potential energy. If we want to get mass by itself, what needs to move? What else is with mass? Height, so I'm going to divide away the height. What else is with mass? Gravity. So divide by both of those, G and H. So your potential energy divided by height and gravity gets you mass. If I want to get G by itself, what do I need to do? Divide by M and H. Just one M. So that cancels those. So gravity is potential energy divided by mass and height. And if I go back to the beginning, mgh, to get h by itself, divide by mg. Potential energy divided by mass and gravity. All right. Oh, thank you. All right. We're making up, let's say, Tyler's on a plane. The plane has a mass of, I don't know, 1,500 kilograms. And is at an altitude of 30,000 feet. What is Tyler's potential energy?
I don't know. Isn't this hard?
I mean, that is one of the tests.
I'd rather do it harder than
Yeah. Sorry, you need this to graduate. Okay. We've got the 1,500 kilograms and the 30,000 feet. Let's say, but actually that should be in meters, so that we don't have to change anything. What else do we need though? The 9.8 for gravity. So we have mass is 1,500. Our gravity is always 9.8, and then our acceleration, no, height,
30,000.
is 30,000. Yes. So multiply those three things together, it's going to be huge.
440.
How many zeros?
6.
6 zeros afterwards. Don't fall out of the plane, Tyler. That's a lot of energy to use. Sounds fun. Just make sure you're wearing your parachute. And what? And the helmet? Yeah. Yeah, right. Oh my gosh. Sure, our little bouncy ball from our experiment. Ow. I don't think they'll make it. I think that's a lot of energy. Gonna pop any of them.
It makes me draw a kickball.
A kickback? Yeah. It might not withstand its energy and just explode in the air. Don't get on a plane. Hopefully nobody's beneath it, because that's a lot of energy and it will hurt. Probably kill somebody.
I mean, a dodgeball?
You'll definitely die if you go where a parachute
That's a lot of kinetic energy. I mean, potential energy. That's going to turn into a lot of kinetic energy,
which is going to kill you.
which will hurt and possibly kill you.
Energy for that?
What?
You figure out the kinetic energy from 440
Let's pick something smaller so that it fits in our calculator. If you want to figure that out, you can. Okay, so moving on to kinetic energy, what is your formula for that?
1 times mv squared.
Yeah, 1/2 times your mass times your velocity squared. Make sure your velocity has that second power. So if I want to get mass alone, this one's a tiny bit different.
So would joules be velocity?
No.
And how would I figure out?
We'll get to that in 1 second. If I want to get this mass by itself, what has to happen? I have to multiply by what number? The 2, because it's on the bottom of a fraction. So this has an extra step. I have 2 times my kinetic energy equals mass times velocity squared. So what do I need to do to get mass alone?
You square v.
What is the v doing to the m? It's multiplying still. So I still need to divide. What needs to be divided? Velocity squared. It gets to take the square second power with it. So then mass is just 2 times kinetic energy divided by velocity squared. Okay?
Aren't all of these coming
Yeah. So like it's comprehensive or cumulative, that's the word I mean. Everything we've talked about. Because it's like your final for this section.
Wait, so like if we're gonna have to find kinetic energy, mass, velocity, potential energy, mass, gravity.
You might not have to do every single one for each type, but each type of problem will be on the quiz. So like you might only have to find kinetic energy or find the mass if they give you the kinetic energy. But there will still be like the speed stuff will be on there again also.
So can we like write these down?
Yeah. Have you been?
I'm just saying like to use for our test.
Yeah. You can use this on your test since it's more information. Starting this one again, kinetic energy is 1/2 mass times velocity squared. Hello. What needs to happen to get velocity by itself? We still need to multiply. So we have 2 times our kinetic energy equals mass times velocity squared. What needs to move next? The m, and how do you move it? Divide n on both sides. So 2 times kinetic energy divided by mass equals velocity squared. And we have to get that square off of there, and the opposite of a power is a root. So velocity is the square root of 2 times kinetic energy divided by mass. That was a little bit different.
Is that one of the ones? But don't we have to divide it by the 2?
I did use the 2. Sorry if you're watching the video, I forgot to press unpause. We did 1/2 times 1,000 to get the 500. And then that 225 had to be squared. So we used all the parts. $25,312,500 joules. Okay? Questions about potential or kinetic energy? Okay, Tyler, here's where You can compare. What do you know about, what does the conservation of energy say?
Isn't created or destroyed.
Yeah.
It's just transformed into other forms.
Good. Energy cannot be created or destroyed. Yeah. So it transforms into different types of energy. What does that mean about our potential and kinetic energy? They're the same. So potential energy equals kinetic energy, or we could write it backwards, but what they're really going to use this for are the formulas for those things. So potential energy is worth what parts? MGH. Like what letters make the formula? So MGH equals, what's the formula for kinetic? Yeah. 1/2 mass times velocity squared. Remember, since m is on both sides, you can start off by just so you would use the 441 million joules to figure out how fast you were going. Multiply it by 2, and take the square root of it. Very fast is your answer. Okay. What's like the speed of sound? I gotta break the sound barrier. Probably not, but
What happens when you break the sound barrier? What does that even mean?
you go really, really fast.
Faster than sound?
Yeah. Okay. It would hurt, you're right. We're gonna go back to speed and acceleration on this next page and talk about the things we did with graphs. So this is, the way this is typed out might be a little bit confusing. This means your y numbers get subtracted and they divide by your x numbers that also get subtracted. So is a fraction, if you put second y minus first y, that's fine. If you do first y minus second y, that's fine. Just whatever y you start with, you need to start with the same x, like the point, the x from that same point. What I care more about here is deciding what the slopes of these graphs tell you. So if you have, we did two types. We had a distance versus time graph. Distance versus time tells you speed. Okay? So we're going to draw our own little distance and time graph over here. Leave some space because we're going to do a little extra work with these. Which unit goes on the bottom? What is your independent variable? Time. Time's going to keep ticking no matter what you do, right? We're going to say that's in seconds. And our y-axis or dependent variable has to be distance. We'll say this is meters. Okay. 1, 2, 3, 4, 5. I didn't leave myself enough room. 1, And how far up did I go? 1, 2, 3, 4, 5, 6. Okay, so I'm gonna go. What color do I want to do this? Gonna start. If I start moving, I'm at 0. Time hasn't passed, so I'm still at 0. I'm gonna go for a little bit. Make a little straight section. I'm gonna have another going up section. We're gonna go over a little bit. And then we're gonna go straight back down. I'm going to label these sections just A. Actually, put that on the other side of there. Oops. A, B, C, D, and E. So if this is a distance versus time, a speed graph, what's happening on your flat sections? They're not moving, they're at rest. What about at E? But this is an acceleration graph, this is a speed graph. The slope would tell you that they're braking. But if you're going, my distance at the top here, not just slowing down. If I was at the top here, I'm going backwards, I'm going back home. So the slowing down is for acceleration. For speed, you're just moving backwards. And then let's find the slope of the C section. So what do you need to know before you can find the slope? Yeah, we need the numbers for these points. So I have this point here, and C ends up here. So what is this number going to be? 2, 2. We went over 2 and then up 2. And the end of that section, pretend that's matching. Three, 5. Okay. So we have x, y, x, y. How do you find the slope? Subtract. Which one goes on top?
Y.
The y. So it doesn't matter which one you do. We can go ahead and do. If I have 2 minus 5 on top, what needs to be on bottom? 2 minus 3. It doesn't. If you did 5 minus 2 and 3 minus 2, that's fine. We should end up with the same answer. Negative 3 over negative 1 equals, whoops. Yeah, a negative divided by a negative is a positive. And what is our unit going to be here? What was the, yeah. The y-axis was meters, the x-axis was seconds. Okay, so that's distance versus time. All right, and we're also going to do an acceleration graph, but what is acceleration comparing? Speed versus time. So same thing, we're going to draw a speed versus time graph. Time is still your independent variable, so it goes on the bottom. Now our speed is the x. It's going to be meters per second. 5. We're going to change this one up. We're going to do by 5s. All right, so we're still starting at 0, 0. Then at 5 seconds, we were going real fast. Go up to like that. We'll say this is 9, 5, 9. Then we're going to do a flat spot on the top here. Going to go in the middle here, come down a little bit, and have another little flat spot. And then from there we're going to go straight down to the bottom. Whoa. Again, we're labeling these A, B, C, D, and E. This time, what do your flat spots mean? It's not accelerating, but if you're going at constant speed. So like you hit your cruise control. So you're not speeding up, so your acceleration is 0, but you are still moving, just at a constant speed. This time, what do your downward sections mean? This time you are slowing down. Your speed got less. Let's find the slope of section A. What are our points for section A? 0, 0, and 5, 9. What order do you want to put those in?
0 minus 5, and then 0 minus 9.
What has to go on top? The y numbers. So 5 is an x. I thought you said 5, sorry.
Oh, I don't know why I said maybe.
So 0 minus 9 on top and on bottom. will be 0 minus 5. What are we going to get when you do the subtraction? Okay, and then that's going to be, you're not subtracting, you're going to divide that. What is 9 divided by 5? Okay, what does the slope mean in this graph? 1.8 what?
Meters per second squared.
Meters per second squared. This is acceleration. Okay? Questions about the graphs? Okay, last thing here was our net force drawings. So if a force is pushing from the left, your box is going to move to the right. If your force is pulling to the left, which way is your box going to move? The top one moved right because we were pushing it that direction. If you're pulling, it's going to move left. If we push from the right, which way is it going to move? Left. Whoops. And then if you pull from the right, it's going to move right. All right, and then we have two opposing forces. How do you decide net force? You have to subtract. Okay? 30 minus 25 leaves 5, but you also need a direction. So this is 5 newtons which way?
Right.
So the 25 is smaller, so the 5 is going to keep going to the right. So you need to subtract to find the net force. One last thing before we call it quits. All of these forces have to do with Newton's laws of motion. So just what does the first law say? Yeah. First law, if something's in motion, it wants to stay in motion. If it's at rest, stays at rest. How do you get them to... Yeah, unless there's an unbalanced force. If something bigger than it moves it, it will go. Or if something bigger than it stops, it will stop. So object at rest stays at rest. In motion stays in motion, unless an unbalanced force changes that. Okay, our second law we've actually already talked about. It's just our force formula. Force is mass times acceleration. And then Newton's last law says what? Yep. Good. For every action, there is an opposite but equal reaction. Or forces come in pairs. If you're pushing on the table is pushing back on you. Go ahead, put on my desk. Okay, any questions about physics? You're almost done, guys. One more day.